So now we're going to focus on shifting up and down. So if it's +4, if you go from the red to the blue, did it go up or down?
Oh.
Up. Yep. And if I put like -3, it goes down. Okay, so the rule here is if the number outside the x squared, if it's negative, it goes down. And if it's positive, it goes up.
Okay, let me write that.
So yeah, I'm going to write that down, but you've got to have the visual here also. So and then we'll do the do some practice. Let me back to the other screen here. So if you want to shift up, it's x squared plus a number. And if you want to shift down, it's x squared minus a number.
Shift up is x squared plus a number. Oh my gosh, yeah, this is a lot to memorize.
Well, there's more. This is just the basics.
Yeah.
So let me
Okay, let me just get all this down really quick. Okay, almost done. Okay, got it.
all right.
Yeah.
Okay, so where we're going next is I'm going to give you a graph or an equation. Sorry, I'm going to give you an equation here. I'm going to say x minus 2 squared plus 3, and you need to tell me whether this is going left or right and how much, and then whether it's going up or down and how much.
Okay. So that is shift right
Okay, how many?
2.
Okay, and is it going up or down?
Down.
Why down?
Because of the negative.
The negative's on the inside.
Oh, you look at the plus on the 3.
Yes.
So you're going down. Okay, then up.
It's going up, and how many?
3.
Very good. Okay, let me go back to the graph. Let's graph that. And let's take a look at if you're right or not.
Okay.
Good chance you're correct here. So x minus 2, not z, x minus 2 squared plus 3. Except I didn't do that right. Okay. Now, what is this point? What is this point down here at the bottom? Do you remember what that's called?
Oh, the vertex.
Vertex. So the vertex is 2, 3. The vertex of the original is down here at 0, 0. Did the vertex move 2 to the right and up 3?
Yeah.
Yeah, it did. Okay. So that's how you confirm whether or not you've got it correct.
Okay.
So we talked a lot last time about the vertex from the equation. So remember how that we looked at this equation x minus 2 squared, and you would tell me the vertex is 2, 3.
Yeah.
Do you see how those numbers map to the transformations?
Yeah.
They're exactly the same. So if you can find the vertex, you can find the transformations, at least the start of them. Okay, let's look at another problem here. Y equals x plus 1 squared minus 2. Again, I want to know whether it's going up or down. I'm sorry. You don't start with up or down. You go right or left. Right or left. The order does matter, and by how much.
Okay.
And obviously
So
you could graph these, but I'm hoping you can do it by hand.
it
Yeah, go ahead.
goes left one left,
Okay.
and then it goes. Wait. Oh, sorry. Oh my gosh, it goes down 2.
Okay. So where's the vertex?
The vertex is 2.
The vertex is an ordered pair.
Oh, the vertex is 2 and 1. Or no.
No, no. If you're not sure, let me graph it and then we can
Yeah,
look
yeah,
at it.
yeah. I'm a little
Okay.
confused.
All right. So let me go back to the other screen here. There we go. All right. So we got x plus 1 squared minus 2. Okay. So what is the vertex of that?
1, -1, and -2.
Yeah, -1, -2. Okay. Now, do you remember what we said for the transformation? You said it was going to go left 1 and down 2.
Yeah, I did that wrong.
No, you did it right. You did it completely right. Okay.
So why is it negative like wait?
So they're both true. Let me go back to the other screen. The- Okay, so if you're seeing my screen here, this is correct. The transformation are correct. It goes left 1 and down 2, but left 1 means -1. Down 2 means -2. So the word left and the word down, they negate the number.
Okay. Oh, okay.
There's a little lag there. Hopefully you heard everything I just said.
Yeah, I did.
Oh,
My
fantastic.
internet went out, so I'm using my hotspot.
Okay.
Yeah.
Is it good enough for this lesson?
Yeah, it's good enough. Yeah, it's good enough.
Okay. Well, I never had a hotspot when I was your age. All right, let's do another problem here. So let's say I give you the equation x minus 3 squared minus 5. I want to know left or right and up or down and how many.
In the vertex.
And the vertex, we'll get to or you can do the vertex first. The order doesn't matter
Okay.
to me.
Yeah. So it's negative. Wait, oh my god, why am I overthinking this now? It starts off with going left or right, right?
Yes.
Okay, so it shifts right 3 times.
Okay, so right 3, since right means positive, it's just 3. That's for the vertex.
And then it shifts down -5 times, or yeah.
So okay, so when you tell someone directions, do you ever specify positive or negative?
No, not really.
No. So you just say down 5.
Okay.
But because it's down, it goes to -5.
Yeah. And
And see, and so what I've tried to
yeah,
show you
and
on
then
the
the
right here
vertex
is
is
yes.
yeah, that yeah, that's what I was gonna say. Yeah.
Okay. I think just a little disconnect there from between us, but back to that point here, like if you tell your friend to go right 3, he goes right 3.
Yeah.
But if you tell your friend to go right -3, he should actually go left, which is weird, but that's what it would be.
Yeah. Okay.
So when we specify direction, like you get in your car, Google Maps, whatever, and you like going somewhere, you don't, it doesn't say like go forward -100 miles. It says go backwards, turn around, and then go 100 miles.
Mhm.
We always specify those as positive, but in terms of the vertex, we do that. Any questions on this? Because I want to give you a few more examples before we move
No,
on.
it's good.
Okay.
And that's the transformation or the parent function.
The parent function is what we start with.
Yeah, this is the transformation though, right?
Yes, yes.
Yeah,
So for all of these, our parent function is x squared. And the idea
yeah.
is that you look like your parents in some ways, in some ways you look like them. All the graphs kind of look the same. Okay, so here's another one for you to think about. X plus 4 squared plus 6. I want the transformations and then the vertex, please.
Okay. X plus 4. So it shifts left 4 times. And it goes up 6 times.
Okay, so how does left 4 correspond to the vertex? Is it positive 4 or negative 4?
Negative.
Negative 4, and that's the x value. So that's why the order matters. Left goes first, that's the x coordinate of the vertex.
Yeah. Okay, I got that. And then the 6 goes
So it's positive 6 like
Yep.
that.
Yep.
All right, you ready for me to throw in another transformation?
Sure.
All right, so we're going to go back to the graph here. Let me share this other screen. All right, so the parabola opens up. See how the parabola opens up?
Yep, I do see that.
Okay, if I put a negative out in front, guess what happens?
It goes down.
It goes down. So the wording here is that and I'll write this down, is it's a reflection over the x-axis.
Okay.
You have to
So
specify.
I put negative goes down.
Yeah.
Okay.
You have to specify the reflection over the x-axis. Now let me go back to the screen.
Negative goes down on a reflection.
But you have to say these words in this order: reflection over the x-axis.
Okay.
It's like negative x squared.
Okay, gotcha.
Okay, now that your class, your school doesn't do this correctly, but the order really does matter. I say that generally, like there's some teachers that do this correctly. The order matters. So the reflection in terms of where it fits into what we've been doing, you first shift left or right.
Yeah.
Then you reflect
Okay.
over the x-axis. Then you shift up or down.
Okay.
And you may wonder if it matters, why it matters. We can get into all that, but like this is how you're going to be successful.
Gotcha.
Now, not every problem has all three. Some of them just have 2 of the 3, 1 of the 3. There's a 4th one here we'll get to.
Yeah. Okay.
Things like that. So here's an example problem. Let's say it's y equals negative x squared plus 1. This does not have a shift left or right. There's no shift left or right.
Yeah.
Okay, and if you don't believe me, we can go look at the graph of this. But it does have a reflection over the x-axis.
Yeah. Okay.
So you have to say all that. You have to say reflect over the x-axis, or you can check with your instructor. Maybe they'll just say reflect over x, whatever. The plus 1, what is that for?
To go up 1.
Yeah, we go up 1. Okay, so let's go and look at the graph of this. So notice like you flip it and then you add 1 and see how it goes up 1 from the parent.
So
Like
it reflects only if it's not like x plus a number, but it's just x plus like usually how it's like x plus a number and then another number like added.
Well, we're going to get to that in the next example, but I want you to just see a reflection
Well, how do
and
I
then
know when it's a reflection or not?
the negative in front of the x squared.
Okay, gotcha.
That's what you're looking for.
Alright.
What is the vertex of this one?
0 and 1.
0, 1. Now let's go back to the other screen here and let's try to decide why is it 0. Let me go back to it.
Gotcha.
Okay, so right up here at 0, which doesn't happen, it shifts right, left 0.
Yeah.
That's why the first number is 0, because there's no shift left or right.
Okay.
And then up 1 is the other value.
Yeah.
Okay, so let me see if you think you've got this down. Give you an example to try on your own. Let's say it's y equals negative x squared minus 4.
Okay.
Does this shift left or right?
It shifts right.
No,
Wait. Left. Sorry.
it doesn't shift either way.
Oh, down.
Right, but the order matters. It reflects over the x-axis.
Yeah.
That comes from this negative. The
Okay.
minus 4 is down 4.
Okay.
What is the y coordinate of the vertex? Just the y coordinate here.
4.
Nope, it goes down 4. What does that correspond to?
-4.
Yes, and that's what goes here.
Oh yeah, because it's reflecting down. My bad, yeah.
Since this thing does not move left or right, what is the x value of the vertex?
0.
0. Okay, let's go back and look at an earlier problem here. Let's say it's y equals x plus 3 squared minus 5. Does this go left or right, and by how much?
Okay, this one goes left by 3,
Okay,
and then down 5.
how does left 3 correspond to the vertex? Does it change to negative or
-3,
positive?
negative.
Okay, how about down 5?
-2.
Negative what? Oh, negative also, you said. Okay. Yeah, so the vertex is -3 comma -5.
Yeah,
Now, if I put a negative in front of this,
it turns positive, right?
nope, it does not affect anything we've done,
Okay.
but it does reflect over the x-axis.
Okay.
Now let's look at that graphically. Okay, so I don't know if you have this written down or not, but I'm going to go and share a new graph here,
Okay.
and we're gonna look at this together. Okay, so here's the first x plus 3 squared, like that. So here's the original graph. Here's this one. Do you see that it shifted left 3 like you told me?
Yeah.
Okay, now watch this. We're going to shift it, reflect it over the x-axis. Do you see how the green went to the purple?
Yeah.
Okay, now we're going to subtract 5, so it's going to go down 5. Do you see how the graph moved down 5?
Yeah, I do.
So that's how you piece those transformations together. The order does matter here.
So if it's not a +5 is just this, like, how
Let's
we've
go.
been normally doing
Let's
it.
go
And
plus
then,
5. See how it moves up 5?
I see. And then it goes down 5 on that -5. Okay,
Yes.
gotcha.
So you have to be able to take an equation and determine the transformations.
Yeah.
Let's do a few more examples here. All right, let me give you another. Are you seeing the screen with the graph paper?
Yeah.
All right, so let's try this. Negative x minus 2 squared plus 3. There are 3 transformations.
Yeah.
Okay. And the order matters here. So we're going to start with left or right. Is this moving left or right, and by how much?
That is moving right by 2.
Okay, I agree.
And then
Now,
it's going up 3.
so up or down, that's not, you have to do the order here. The order matters. So you're going
Up.
up 3, good. And what's the middle one here? What does this negative correspond to?
It makes it where it goes down.
Nope,
Right?
reflects
Reflect it
reflects
down, right?
over the x-axis.
Oh,
So if you haven't been writing anything down, I would strongly encourage you to write something down for this one.
yeah. Let me just. Got it. Okay. Gotcha.
Okay, so let's look at another problem here. So let's go y equals negative x plus 5 squared plus 2. So again, really important. You got to do this. You got to do this in the right order. Are you going left or right?
Left. 5.
Left how many? Left 5. Actually, I didn't ask you for the vertex in the previous one. I'll have to go back and look at that. So that corresponds to -5 in the vertex.
Yeah.
And then is it up or down?
Up.
Up 2. So that corresponds to +2.
Yep.
What's the middle thing that's going on here?
Reflects over x-axis.
Reflects over x-axis. Like they expect you to write this on your test.
Yeah, that's good.
Okay. So what is the vertex of this one?
Vertex is 5, -5 and 2.
-5 and 2. Good. Okay, so I think you're getting it down. That's really great. So let's look at you ready to look at a more difficult one?
Yeah.
Transformation. Do you feel like you've got
Actually,
this down?
let's do one more. Like
Okay.
this one.
All right. Negative x minus 3 squared minus 3. So I want you to write down the 3 transformations and then give me the vertex.
Okay. The first transformation, it goes right 3.
Go ahead and you write them down here. Take a moment to see if you've got it. Then I'll check in with you.
Okay, got it. I put right 3 positive,
Right, 3, good.
and then positive, and then reflects over x-axis,
Good.
and then down -3.
So there's an issue with the last thing you just told me. You're always going up or down, left or right, a positive number.
Oh, well, I thought if you go down, it turns into, well, it's just like a negative always. Or,
So it's down 3, but that corresponds in the vertex to -3.
yeah, that's what I'm saying. Is that wrong or?
You can't say down -3. You have to say down 3 or up 3 or left 3 or right 3.
Okay,
It's
I was just
never it's
I was just trying to clarify that I knew like it was like a negative, obviously, or -3. Sorry. Yeah. Okay.
So what is the vertex?
The vertex is 3 and -3.
Yeah, very good. Okay, let's try one more. Let's go y equals negative x plus 4 squared plus 4.
Okay. It goes left 4. Then reflects over x-axis, and then goes up 4.
Go ahead and get them all down.
Okay. Yeah, so left 4 on the first one. Matthew.
Yep, I'm waiting. As you got it, you're like, imagine there's some punishment associated with this. You got it down left
Yeah, left 4.
4. Okay. What's the next one?
Reflects over x-axis,
Okay,
and then up 4.
good. So what does left 4 correspond to at the vertex?
It corresponds to like -4.
Yes. And then +4. So your vertex is -4,
And +4.
+4. Good. Okay, so we're going to go back to the graph and the last transformation.
Okay.
Unfortunately, this one is not captured well, taught well. So it may be that you get some information with me that's different than what you see with someone else. So I want you to look at the two graphs and think about clothing, maybe, or shirts, pants. I don't know. How would you compare blue to red or red to blue? In terms, maybe using like words you might use when you're talking about clothing.
I'm not sure.
Okay. All right. Well, disregard that. Can you give me let me change this number too. Well, how would you describe those two graphs to someone else?
One's wider, one's
Yes.
narrower.
Yes. So the blue one got wider.
Yeah.
Okay. And we're gonna add a little slider here. We're gonna hit the play button. Tell me what you tell me
It's
what you see.
narrower, and then wider and goes down.
Yeah, actually I didn't mean to go negative. Sorry about that.
Good.
0. So it gets narrower, and if you freeze it right on 1, which is really hard to do, they're the same, and then it gets wider and so on.
Yeah.
So the idea here is that if the number in front of x squared, and you disregard the whether it's positive or negative, if that number in front of x squared, if it's bigger than 1, it gets narrower. And if it's between 0 and 1, it gets wider. So that's our last transformation. So let me go back to the other screen and try to summarize that.
Go.
Right here. So y equals kx squared. And there's two cases. If k is greater than 1, it gets narrower.
Okay.
If 0 less than k less than 1, it gets wider.
Okay. Here, let me write this down.
Yeah, this is important to get down. We'll do some examples of this. And because there's some different language that you'll need to use.
Yeah, this isn't too difficult. I just gotta like memorize all this stuff. All right, got it.
Got it all down?
Yep.
All right. So here's an example problem. Let's say it's y equals 4x squared. So here's how you would write the transformation. It's a vertical stretch by a factor of 4. Vertical stretch by a factor of 4. And you have to use those words in that order, just like I've written there. There is no other correct way to do it.
Okay. Vertical by factor of 4. Okay. All right.
So let's say it's 1/2 x squared. We talked about getting wider, right?
Yeah.
So the problem here is there's like the correct way to write it, and then there's the way you'll probably see it in class. And I don't know what to do, because if I tell you the correct way, it could confuse you. If I tell you the way they'll do it in class, it's wrong, or most of the time it's run wrong. So I'm not sure what to do here. Because it's not a vertical stretch anymore. But it's also not a horizontal stretch. So we'll just go with the standard wording here. Maybe that will be the best. Vertical stretch by a factor of 1/2.
Okay.
Okay, so now we have 4 transformations, and here is the order that you will do the transformations in when you write them down. The first is you're going to do left or right.
Okay.
Then you're going to do, and this is 2 and 3, you can actually move back and forth. We'll just stick with reflect over the x-axis. And then the third is a vertical stretch by a factor of, and then the last one is whether it's going up or down.
Okay.
Okay, so keep this in mind for the next problem here. We're gonna have all 4 transformations in this.
All right. Should I write that down too?
Well, you'll see it. Well, I mean, you can. It's good for us to do.
Do you recommend me
But
to?
yeah, I would write it. Yeah, I would write it down. I would write it down. Left to right, reflects over the x-axis, vertical stretch by a factor of, and then up or down.
Okay, give me a minute. What is that one word on number 3?
Vertical stretch by a factor of.
Got it. Okay.
Okay, so here's a problem that's got all 4 transformations in it. -3x minus 2 squared plus 4. So we're going to go in order. That way we get them all down in the right order. So this one is going left or right, and it's from this x minus 2.
Right to.
Right to.
Yep.
Reflect over the x-axis.
Yep.
Now, what some students do is they sort of like mark off what they've dealt with. They're like, all right, I dealt with that, I dealt with the
Yeah, that's
negative.
what I would probably do. Yeah.
Okay, that's real good. The next is the 3. It's a vertical stretch
By 3.
by a factor of 3. That word
Okay.
factor is super critical.
Okay, I'll write that down. Just always write factor when you're doing that. Okay. And then it's
The last
up
one is
4.
up 4, yeah.
Yep. And then
So
it'll
the
be
next,
4.
so the next thing here is to determine the vertex. So does that right to correspond to +2 or -2 in the vertex? +2. And how about the up 4?
Yeah. Also positive.
Yeah. So the vertex is 2, 4. And that's another thing that you would be asked to do in a problem like this. So there's a
Okay.
lot. I mean, there's really a lot. We built up to it.
Yeah.
Okay.
Got it. Okay.
All right. So let's look at another one here that's got all 4 of them. It feels like a lot. It is a lot, but just if you go through it sequentially, you have a chance here to do it right. So let's go minus 5x plus 1 squared plus 3. Okay, so let's see if you can get the transformations down.
Okay. So you go left one,
Okay,
and then it is flex over x-axis.
okay, reflects over x-axis.
Then it's a vertical stretch by 5. Or no,
Yep,
no.
by a factor of 5.
Factor of 5. And then 4 is, oh, sorry, up 3.
Okay, so now I want the vertex whenever you.
So it is -1 and 3.
Perfect. That's awesome. Okay, so reality is that the reality is that you're not going to get all 4 because that makes it too easy, right? You can just pattern it and say, all right, I'll I'll do them always in this order. So you're gonna get problems that are look like the following.
Yeah.
Y equals 2x squared plus 3. This only has 2 transformations.
Yeah.
I'll take them in either order.
Okay. Oh my gosh, this is so okay, I know it goes up 3.
Check. This is like Wheel of Fortune. Got
Yeah.
one of them.
I have
What's the where's the 2? Tell me, like, is
it's
it left?
positive.
Tell me, where is it in relation to the x squared?
Right. I think
The
it's
2
I think,
is left of the x squared.
wait, why?
I'm just asking where it is visually.
Right, I think. Wait, what do
Okay,
you
so
mean?
to me that's right, and then if something is left, it's this other way.
Yeah.
Okay, so to me that this number 2 is to the left of x squared.
Why?
Visually, like visually, it's to the left of it.
Oh my gosh. I
Okay,
thought you were saying what do you think 2 is on the
no,
graph?
no, 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 no. I'm sorry. So I want to go back to this previous problem. Where is 5 relative to the x? Is it left of it or right of it?
Left.
Left of it. So
Yeah.
this 5, whatever was out in front's maybe a better language. It's always a vertical stretch.
Okay.
So this is a vertical stretch
By 2.
by a factor of 2.
Okay. So it would just be the vertex though would be 0 and 3.
Yeah, exactly. Yeah,
And then
perfect.
it would vertical and then it would stretch by 2.
Yes.
Okay, I got it.
So let's look at another one here. This also has 2 transformations. Can you
Okay,
tell?
so first one obviously it goes down 3.
Order matters. That's the second one, but yeah, go ahead.
Oh yeah, sorry. And then that one, not really sure. I'm not gonna lie. This is just a 0.
Let's go back and look at a previous problem here. What did the negative do in a previous problem?
Um, it went right or reflect. Sorry,
Reflect over
x-axis.
the x-axis. So the negative always means reflect.
Well, there's no number there, so.
It's okay. Sometimes it's not a number.
Oh, okay. But then the vertex would just be 0 and 3, 2.
It does not shift horizontally, right?
Mm-mm.
So the x coordinate of the vertex is 0. What's the y coordinate?
3.
Nope.
-3.
Yeah.
Yeah. Yeah. Got it. Okay.
All right. I think we got time for at least one or two more.
Yeah.
So like I said, they're not going to be like all four. I mean, that's too, too nice. Let's go 5x squared minus 4. Two transformations on this one.
Okay.
Again, I'll take them in either order.
Negative. Oh my god, it goes down 4 on number 2.
Down 4. Okay, good.
And then it so I'm trying to find the right words. Reflects 5 factored.
Nope. Nope. Nope.
It goes up.
So when there's a number out in front, it's a vertical stretch by a factor of
vertical stretch. Sorry, I need a vertical
yes.
stretch.
Yeah, vertical stretch
Oh, I already wrote that. Oh my god. Yeah. Okay.
by a
So vertical
factor.
stretch by 5.
Yeah.
By 5. Sorry.
I mean, I know it's easier if I gave you all of them, but that just won't be reality. So that's why we have to keep doing this kind of
That's good. Yeah. That's
test,
good.
checking, do you get it? Do you get it? Yes or no? Okay. How about negative x minus 2 squared? This has two transformations as well.
Okay. It's the first one I think is vertical stretch of just x. I think.
If you could see me shaking my head, you would realize like that we're way off here. I'm not sure what happened. We really were doing really well. Sometimes this happens. You seem to do really well when there's 4 and we can go in order.
Yeah. It's just wait. So wait, let me think about it. Look at my notes. Well, there's no number in front of it, so
Right. But what's happening is I'm trying to give you a more simplified problem, and it's somehow it's becoming more complicated than that.
well, what do you do when there's no number? You just leave it as an x?
Well, let me give them to you here. This negative is a reflect. Sorry, that's not the first one we do. The first one is we haven't done one in a while, is right 2.
Yeah. I knew that. I
Okay.
was just trying to start off with the harder one.
And then reflect over the x-axis.
Okay. Yeah, that did I say reflect over the x-axis? I said stretch, right?
You stretched by x.
Yeah, okay. Yeah, no, I don't know. And how do you reflects by the x-axis because there's a negative, right?
Yes, that's exactly right.
Right. Yeah, I just get used to sometimes like doing like stretching and then it's like, I don't know.
Okay, well, we're pretty much out of time here. I've got a tight schedule, so I apologize. I can't go any further with this, but be
That's
happy
okay.
to tackle this again. I mean, you did really well for
Yeah.
75-80% of this where you were getting it. So
Yeah.
don't lose hope or confidence.
I'm gonna do some more and then I think I got it for sure.
Sounds good. Have a great night.
Cool. Do.
Bye. Bye.